Alright, continuing on where we left off, now we're going to talk about photometric lights inside of 3ds Max. We've already gone over the standard lights, so let me show you how the photometric lights work. Okay, I have the same scene open and I have no lights. I've deleted and gotten rid of all of the lights in the scene, so all I have now when I do a render is the default global light across the entire scene. So this is what I get. Not very pretty. Alright, so you're probably wondering, what are you talking about? What is a photometric light? Well, a photometric light in 3ds Max is a special kind of light that is especially useful for doing more realistic renders. Photometric lights take advantage of profiles, light profiles such as Ies light profiles that are provided by lighting manufacturers. These light profiles contain data, 3D data, and this 3D data is used by 3ds Max to compute the 3D light distribution and intensities of a light. If that made no sense to you, that's okay. It probably shouldn't have made sense to you. But now we're going to actually go ahead and create some photometric lights, and then it's going to make perfect sense to you. So let's go ahead and do that. I'll go over here to the Create panel and switch over to Lights. And you'll see that we have a drop-down list here with standard lights, which is what we've been using so far, and photometric lights, which is what we're going to be using right now. So let's go ahead and create a photometric light. When we switch to photometric lights, you'll notice that we only have these three options. We have a target light, a free light, and a MR sky portal. Not Mr. Sky Portal, that's MR for mental ray. Now we're not using the mental ray renderer, so the mental ray sky portal is not going to work. So we're just going to use the target light and the free light. Now the target light and the free light are exactly the same. The only difference between the two is just the same with the standard lights. The target light has a little target indicator that you can use to point the light, almost like a flashlight or a spotlight, and the free light simply doesn't. It's simply free to aim and point wherever it wants. So let's go ahead and work with the target light. I'll click on target light, and now you get this window that pops up. Don't be afraid. All it's saying is that you're creating a photometric light. 3ds Max recommends that you use logarithmic exposure control when using photometric lights, obviously so that you can get the most realistic and physically accurate results. So, I can hit yes, switch me over to logarithmic exposure control automatically, or I can say no, leave the scene as it is, I don't want any exposure control. What I'm going to do is I'm going to hit no. Now what I should have done was hit yes to create logarithmic exposure control automatically, but I'm going to show you in a moment why I chose no. Now I'm in the light creation mode, so I'll go ahead and let's click over here and just drag and let go of the mouse here to create the point or the target object. Okay, I'll right click the mouse button to go ahead and just end that creation process, and then I'll use the move tool and move this light a little bit overhead like so, almost like we have some kind of ceiling light over there pointing this way like a spotlight. Okay, now if I hit render, this is what I get. I get a very dark scene here. This is the standard photometric light. I didn't change it and I didn't alter it, I just created it and placed it in the scene. So I get a very dark render. Okay, now let me close that. Now let's go back to the whole thing about the logarithmic exposure control. Let's go to the environment and effects options window. Let's go to the rendering menu up here, and we'll go here to environment. The shortcut key is 8 on the keyboard. And I'm sure that you're familiar with, or at least remember this somewhat, the environment and effects window, where we have effects and environment. Okay, now if you remember, I did say that we were going to come back to this later and it was going to play a role with our lighting. Well, this is that time. Logarithmic exposure control can be accessed from down here in the exposure control parameter rollout. As you can see, we have no exposure control. The reason for that is because by default we don't have any in a brand new scene in 3ds Max. Now, when we created a photometric light a couple of minutes ago, 3ds Max asked us if we wanted to go ahead and automatically switch over to logarithmic exposure control. I said no. If I had said yes, the only thing that would have happened was 3ds Max would have come in here and activated logarithmic exposure control. So we'll go ahead and activate it manually. The reason I did that was so that you can see how to activate it manually and have a better understanding of what's going on under the hood, so to speak, when rendering in 3ds Max. Okay, so now that I switched over to logarithmic exposure control, let me close that window, I don't need it anymore. I'll do another render, and now you notice that this render comes out a little bit brighter and you can see things more clearly. So logarithmic exposure control works great with photometric lights. Now one thing to take into account about photometric lights is that they're physically accurate. Photometric lights always take into account the scale, the scene size of your actual scene. So it's looking at the actual scale in units of the scene. How can we check the units of the scene? Well, let's close this window. Let's come up to Customize. Now let's go to Unit Setup over here. When we open that, we open up the Unit Setup window. What this allows us to do is to set up the units of our scene. So we can set up metric units. We can set up US standard units, so we can use things like feet and yards and inches. Or we can do metric, the metric system over here. And we can switch to meters, centimeters, kilometers, etc., etc. I think you get the idea. By default, it was set to generic units. We can set it to whatever we want. I'm going to leave it at the default for now. I just want you to see this because it's important to use the correct scene scale when working with photometric lights, because 3ds Max will take the scale of your scene into account. So I'll just hit cancel on that. Alright, and finally, the photometric light will always have a decay attached to it, or a decay activated for the light, and it always uses inverse square. So we spoke about that earlier with the standard lights in terms of decay and simulating more realistic lighting in 3ds Max. So now let's move along a little bit quicker here, and let's move to the modify panel so we can see what kind of parameters are associated with this light and what we can change. I'll go ahead and do a render here just so we can see what's going on. Okay. Alright, so the first parameter rollout is the templates parameter rollout, where we can open up this drop down list and we could select different templates of real world lights. So we can select from light bulbs, we can select 40 watt light bulbs all the way up to 100 watt light bulbs. We can also select from an assortment of halogen lights, recessed lights, fluorescent lights, and even some other interesting lights such as a 400 watt street lamp and a 1000 watt stadium light. So you can see how these templates can come in very, very useful. Now, one important thing to take into account. These are just preset templates that come with 3ds Max 2009. Realistically, however, you can go to light manufacturers and you can obtain Ies profiles of their lights. So these are just some presets to get you started. However, you can go to light manufacturers, as I said, and you can actually download or acquire through them Ies profiles that you can plug into 3ds Max that simulate all kinds of different lights. So if a specific type of real-world light isn't in this list, try to track down the manufacturer that creates that type of light, and then you can contact them and try to get yourself an Ies profile of that light to put in your scene. This is extremely handy and useful for architects or other visualization artists who are trying to do architectural visualization and need to get the photometric light of a specific real-world light to look exactly the way it's supposed to inside of 3ds Max. So that's extremely helpful. Let me go in here and I'll just go ahead and pick, say, let's pick a recessed 250 watt wall wash web light. Go ahead and select that, and you can see the icon in the viewport changes to show us that we're using that specific light. So I'll go ahead and do a render and you can see the type of lighting that we get. We get this very nice interesting lighting, this nice photometric lighting which looks more realistic, and you cannot achieve that kind of lighting using a standard light. You can only do that using a photometric light in 3ds Max. So let's go over here. After we switch to that type of light, we can see we get a new parameter up here. And this is the distribution photometric web parameter rollout. If we go ahead and click on this button right here, we can actually load up different Ies profiles. Now these Ies profiles are the ones that come with 3ds Max. You can see they get a little thumbnail here that shows the light distribution in red of how the light is distributed using this specific profile. So you can see we get different types of light distributions based on the different profiles we get. That's why it can be very useful to go to a light manufacturer and acquire this 3D data from them so you could plug it into 3ds Max. So you can see we do get some very interesting light profiles here. So you're not limited to just these. You can go to light manufacturers and get some new ones from them. You can also have the options here of rotating the light in the X, Y, and Z channels here. So you can go ahead and say rotate this in Y, and we can see that we did rotate this in its Y axis, so now it's facing this way. I'll go ahead and place that back at 0. Do another render, and there we go. Okay, so that's the distribution parameter rollout. We also have shadow parameters, just like we had with the standard lights. We could change the color of the shadows, the density, and so on and so forth. If we go to shadow map parameters, we can control the shadow map. In this case, by default, just like with the standard lights, we're using shadow maps, which you can change the resolution here to make them look crisper and nicer. We also have atmosphere and effects, so we can click on add here and we can add a volume light effect or a lens effect to this light. We also have advanced effects, so we could change the contrast here. We can also set the light to only cast ambient light, for example, or only diffuse or only specular, or both. Okay, and down here is the templates rollout, where we can go and say, okay, I don't like this type of light, this recessed 250 watt light. Let me switch over to, say, a 60 watt light bulb or anything like that. So you can go ahead and change back and forth right there. Under general parameters, just like with the standard light, we can activate shadows. So I'll turn on shadows, and there we go, we have shadows now. We can also switch from shadow maps to all the other shadow types, including advanced ray trace, regular ray trace, area shadows, and so on and so forth. So that's extremely useful. Then down here we have a very interesting parameter that pertains only to photometric lights, and that's the light distribution type. Right now we have photometric web activated. We can switch to a spotlight model, so we can see how that looks. Looks more like a spotlight, not very interesting. We can switch to uniform diffuse. We can see how that looks. And then we can switch to uniform spherical, which will look a little bit different and mimics more a spherical light fixture. I'll switch back to photometric web because it looks the most interesting. Under intensity, color, and attenuation, we have a different set of parameters. It's not what you're used to with the standard lights. Instead of having just an intensity multiplier parameter and a color parameter, we have something that's a little bit more interesting and a little bit more complex and deeper than the standard lights. For example, if you're familiar with lighting and you're an architect or an engineer and you're familiar with the different types of light illumination factors here, we can switch from D65 lighting to D50. We can also switch to other presets such as fluorescent lights in light whites and warm colors and cool colors. We can switch to halogen lights. We even have xenon lights over here, incandescent lamps and mercury lamps, and a whole bunch of different lamp presets that we can choose. I'll stick with D65 for the moment. The color here, or the color profile of the light, is going to determine, as you probably guessed it, the color of the light. D65 is considered to be internationally neutral color, the color of about a midday neutral gray sky. So it's practically a white light. We can also switch that over to Kelvin, however, and change the color of the light based on color temperature. So you can use actual physical color temperatures from the real world and just plug them in here. So D65 is a color temperature of 6500, and you can see that we get back to D65, which is white. And you notice that this little color swatch on the right goes ahead and gives you a color preview of how warm the light is or how cool it gets. So if we increase the temperature by a lot, we get a very, very bluish light. If we lower the temperature, we get a warmer type of light, closer to orange and red. Okay, we can also use filter colors. So if I switch this back to 6500, which is the equivalent of a D65 light, I can go ahead and render that out. That'll come out white. But I could take a filter color, which is similar to putting a color filter over a light bulb and altering the light of the color of the light, as you can see. So it creates some very interesting and realistic effects. Let me put that filter color back to white. Now those parameters are going to control the color of the light. To control the intensity of the light, we have three different options. In 3ds Max, we can control the intensity of light using three different scales. We can use lumens, we can use candelas, and we can even use lux. So if you're an engineer or an architect, you're probably familiar with these, and you'll probably have a good idea of which type of light scale you would like to use to determine the intensity of your light. So if we switch over to lumens, for example, we can go ahead and set the luminance value of the light. Down here under dimming, we have a resulting intensity parameter. I'm going to go ahead and turn that off. That way I have access over here to my intensity parameters in lumens, candelas, or lux. Let me go to lumens. I could set the intensity in terms of lumens. So if, for example, you know for a fact that a certain manufacturer creates this light at a luminance value of, say, I don't know, 6,000, we can plug that in and then render, and you'll get the exact luminance value that you were looking for. Okay, I put that back to 4,000, how it was before. More subtle, looks nicer. Okay, if you're not working in lumens and you're working with candelas, you can just switch over here to CD, which stands for candelas, and type in your luminance value in candelas. If you're working with lux, you can type in the illumination value of lux, and then you could type in right over here on the right the distance at which that illuminance was measured. Okay, so let's switch back to lumens over here. Now down here in the dimming, if we turn this checkbox on, what we can do is control the intensity of the light using a percentage spinner over here in 3ds Max. Now right now the resulting intensity is 4,000 lumens because we're at 100%. In other words, the light is casting 100% of its desired luminance value, which in this case is 4,000. Now if we wanted to knock that light down to 50%, what will happen is that the light is going to lose half of its brightness because we cut it down by 50%. So now the resulting intensity is only 2,000 lumens, which is half or 50% of 4,000 up here. So that's how that works. I'll go back to 100%, and in fact I'll uncheck that. Okay, and let me actually check it back on so I can show you what this parameter does down here. Incandescent lamp color shift when dimming. What this parameter does is, well, let me show you. Let me take this spinner and knock it all the way down to something really low so this light is very, very dim. You'll notice that the light gets dimmer, but it retains its white color. What this option does is it simulates an incandescent lamp in real life. In real life, if you take an incandescent lamp and you dim it down really low, the color is going to go ahead and change into a sort of warmer hue, as you can see here when I render this out. As I get brighter and closer to the full intensity of the light, it becomes closer to the color that we selected for the light. So it gets closer to white, as you can see. So it brightens up and turns whiter and whiter and whiter. And as I dim the light down, it gets more yellow and yellow and yellow, just like the incandescent lamp would in real life. So I'll go ahead and uncheck that, and I'll uncheck this dimming parameter here. If we go down here, we get a shape/area shadows parameter rollout. What this does, it determines how the shadow is going to be projected from this light. Right now by default it's set to point. If we go to the drop down list, we get different options. We get line, for example, which can give us a little bit more interesting shadows, and it tries to imitate shadows based on a line or a light that's sort of linear here, sort of like a long fluorescent light tube. We can also select rectangle here, and rectangle is going to try to simulate light coming in through some kind of rectangular shape, say like a skylight on the ceiling of a kitchen or a room or an attic or anything like that. And then of course we have other shapes such as disc, sphere, and cylinder, which you can go ahead and use to imitate lights that are more similar in shape to a disc or a sphere or a cylinder. So you can use whichever one that you want. Now with point light, I don't get many options down here. In fact, I don't get any. If I switch to say sphere, I will get a couple of options. I'll get a radius option here, so I can control the radius of the sphere. So you can see I can make the sphere larger or smaller, and you can see here in the viewport it does get larger and smaller. Now if I render this out, it takes a little bit longer to render. That's because with a sphere shape you get shadow samples down here. Now the shadow samples are by default set to 32. I recommend you stick to 32. 32 renders out pretty good quality. If your renders are taking too long to render, or you're just doing preview renders, you might want to knock this down to something like 4. and the shadows will come out a little bit grainier, which you really can't tell here in the render, but the shadow quality will get lowered in exchange for an increased boost in rendering speed, which is great. So let me switch back to 32. If you check on this light shape visible in rendering parameter, what will happen is that the light will become visible in the renderer. Okay, you might want to edit that out of the video because it didn't work. So starting again in 3, 2, 1. Alright, so moving along here, we have again shadow parameters for this light. We have shadow map parameters because we're using a shadow map and not area shadows or ray trace shadows. And again, we could plug in atmosphere effects and so on and so forth. So pretty much all the parameters are the same as a standard light, with the exception of the intensity and color parameters, which are located over here. They're totally different from a standard light and work completely different. Takes a little while for you to get used to it if you're used to standard lights and not photometric lights. Down here under the shape and of the area shadows parameters, we have different types of parameters here which work a little bit differently than the standard lights. And then up here, of course, we have different templates that we could plug in, and of course we have our distribution and photometric web parameters. So with the exception of those key changes and differences between standard and photometric lights, everything else is pretty much the same. So just remember that photometric lights work great for doing more realistic lighting and mimicking and imitating 3ds Max real world lights from actual light manufacturers. So there you go. That's how photometric lights work. Take advantage of them. Use them if you're doing architectural scenes or if you're just trying to get extra realism in your renders.